Thank you guys so much for joining us today. This is our second trivia night for AMS Weather Band. If you were with us in the fall, we had trivia that was focused on tropical cyclones and some information on those. As Gideon said, I'm going to give it a couple more seconds with the instructions and the QR code. You should be able to, if for some reason it times out, or you get knocked off, you should be able to rejoin via the Mentimeter or the Menti code that's located on the screen right now, but it'll also be on all the slides as well. Just a couple of little things. As Gideon mentioned, we're going to be asking the questions and expecting the answers from you. If you do have a question, though, a little bit more in depth, I am joined by Ashton Robinson Cook, who I'm going to give a huge shout out to for helping put some of the questions together. And he is also in the back end to help me answer questions, but also provide a little bit of context as we go through. So we've got about 17-ish questions that we're going to be asking. We're going over 3 topics. We're going to be talking about the science of severe weather, some severe weather safety, and then we're going to talk about some historic severe weather events. So I'm going to go ahead. We're going to move forward on our slides here. And again, I just want to give a huge shout out. Ashton and Ted helped pull this together, pull the questions for that you guys are going to be answering today. It's going to be a really fun experience. I'm going to go ahead and I'm going to prompt the screen to go to the next couple of slides. So we're going to start off with our category of science, the science of severe weather. The next screen is going to prompt everyone to log in. So if you have not given yourself a username or anything like that, this is the time to do so. Your icon will appear on your screen, on the screen here, but it'll also appear on either the mobile device or the web browser that you are currently using. You will have, for this particular section, I'm giving 20 seconds to answer the question. The faster you answer and get the correct answer, the more points you will receive. Now, the great thing about Mentimeter is it keeps track of the points. I don't have to worry about doing any of that. We are going to start off with the question. And it's going to do the countdown. Once we either hit the countdown or everyone has answered the question, it's going to provide the answer. We're going to take a couple seconds after that, probably closer to a minute, the way I talk, and go over the science or the reasoning or the actual event that was the correct answer for each question. And then we will turn it over to the leaderboard and see where everybody is at that point. So I am going to turn off my screen so you don't have to look at me talking with my hands and you guys can actually focus on the event. Like I said, Ashton is in the background. He's going to chime in whenever he wants to add something, or if you guys have any questions in the Q&A, he can also answer with that. So with that, I am going to go ahead, stop sharing my camera, and we're going to get started with tonight's trivia event. So again, CAPE is an acronym used to designate which of the following these answers should appear on your devices. Is it convective acceleration post-equilibrium, convective available potential energy, the turbulence in a thunderstorm outflow, or the maximum energy available to an ascending parcel of air? Watching the numbers come in. Let's see how many of you got it right. 37 of you got the answer correct, and it should tell you on the screen whether you got it correct or not. So also on your screen and on the screen that you'll see in the Zoom, we're going to just kind of go over a little bit about CAPE. So CAPE, which is convective available potential energy, is the amount of fuel available to a developing thunderstorm. It's typically expressed in joules per kilogram and can range from about 0 to over 5,000. In general, CAPE values are less than about 1,000 joules per kilogram. That's kind of like the weaker instability. About 1,000 to 2,500 is about moderate instability. And then typically anything over about 3,000 is going to be strong to extreme stability. But, you know, there's a sliding scale with this because it was really dependent on the time of year and also the location in which the CAPE is looking at. So these are 2 examples of soundings coming from the UCAR COMET program, and you can kind of see that orange area, which is representative of the CAPE in the 2 soundings, is extremely different based on the temperature and the moisture and the content of the atmosphere that uses to develop that particular CAPE. So Ashton, real quick, is there anything else that you'd like to add about CAPE to our audience today?
Nope, those are really good points and a good description of atmospheric instability.
Thank you so much. I appreciate that. All right, so drum roll, please. We're going to move on and see where our leaderboard is. Wow, you guys are really close right now. So again, we can see who got the fastest. We have a pretty close spread. Now, this is anybody's game, just to let you know. It only takes one person not getting it quicker than you, or misclicking, or not knowing the right answer. So if you don't see your name on the leaderboard, do not despair. All right, we're going to get back and ready for our next question. All right, next question is, which of the following represents a graphical analysis tool of wind shear? Is it a log PSQT, potential vorticity analysis charts, a hodograph, or Corfurti record vectors? All right, 4, 3, 2, 1. And 31 of you got the answer correct. So what we actually look at is a hodograph, and I'm going to show you an example of a hodograph right here. You may have seen some of these posted on social media. You may even see the Weather Prediction Center post some of these out. And so each point on the hodograph really represents the wind direction and the speed at certain levels from the upper air sounding, and sometimes even within forecast and model data. So, it's that series of vectors is drawn in this polar coordinate system at various levels, so we can kind of see what that wind shear actually looks like. The green arrows are drawn to help, so you can kind of visualize the wind field and the different shear. And then you can kind of see those kind of relative to the ground levels. And there's a couple of different layers that are commonly assessed for severe weather when we're looking at hodographs and we're looking at that wind shear. So I've got those kind of listed right there. But this is kind of just a broad example of what an actual hodograph looks like. And I'm going to tap off Ashton in one more time to see if I have missed anything or if there's anything else to add.
No, this is a great description of polar graphs. I know in severe convective forecasting, I use 0 to 1 and 0 to 3 shear a lot to assess strength of mesocyclone, potential strength of mesocyclones, and then 0 to 6 to assess, the overall organization of thunderstorms in general and also complexes.
Awesome. Thanks, Ashton. I appreciate that. All right, so let's see. Oh, hold on. I went back. I went too far. We're going to actually look at the leaderboard real quick and see who got those. And do we have any changes in our leaderboard? Well, we do have some changes around. See, like I said, it can be anybody's game, so don't give up. All right, we're going to move now on to question number 3. Here we go. A supercell thunderstorm with an updraft rotating in a counterclockwise direction in the northern hemisphere will move in which direction? Will it move to the right, the left, parallel, or is it unpredictable? All right, do the final countdown here. 5, 4, 3, 2, 1. Here we go. 24 of you got it right. And the answer is right. So let's just take a little bit look at a supercell structure so you can kind of see where the inflow is on this particular supercell, and you can see it's highlighted with that rotating updraft. It moves to the right because the dynamics of the rotating updraft favor new convective growth on the south side of the storm. And the cell motion will be towards the right of an observer, like that's facing downwind from the particular cell. Supercells are often long-lived. They usually last for greater than an hour, and they feed off of updrafts. So this rotating updraft could be as large as 10 miles in diameter and can go up to about 50,000 feet tall, and can be present for as much as 20 to 60 minutes before a tornado even forms. So, Ashton, do you have anything that you'd like to add on this particular topic?
Yeah, just a small thing to add on. The right movement is relative to the mean flow through the troposphere. So oftentimes that happens through a process called propagation. That's probably a little bit too complicated to get into right now, but the mean flow, if you're looking at a radar mosaic and you see a storm that's moving a little bit to the right of the mean flow compared to the other storms around it, that's probably a cell that's rotating.
Thank you, Ashton. I like having you on here as like my backup so I don't miss any of these things as I'm going through all the questions. All right, let's see what the changes in the leaderboard actually look like. I think there's going to be some changes. Well, we did have some people move around. All right. Got another science related question. Make sure everybody is logged in and ready to go. All right, here we go. So again, remember, if you get the answer right, the faster you get it right, the more points that you actually get. So which of these criteria defines a derecho as a severe weather event? Is it a Boecker signature that is larger than 100 kilometers in length, convective wind gust with a specified time, intensity, or area, an individual cell motion greater than 65 knots, or is it a combination of hail, wind, and tornado reports? 15 of you got it right. So derechos, and this is actually probably one of the more famous derechos, which was the Midwest to East Coast derecho in June of 2012, which spanned about 600 miles. And you can see there were over 500 preliminary thunderstorm reports that indicated the peak wind gusts were between 80 and 100 miles an hour. So these wind damage loss can extend a great distance, more than 240 kilometers. They usually include a wind gust of, at least severe limits, which of course is 58 miles per hour. And, they occur for such a long period of time. And I think, Ashton, you've done some work with derechos and everything. So I'd like to hear some of your additional thoughts.
Absolutely. Yeah, I don't have anything else to add really though for the derecho definition. They're usually long-lived. They usually thrive on, extreme instability, but there can be instances where, weaker instability, but, strong forcing, like a mid-level wave or something like that, can actually cause a squall line to last that long and produce a widespread amount of wind damage. So, yeah, I think you covered this pretty well, Melissa.
Thank you. All right, let's see. Of those who got it right, let's see what changes are going to happen within our leaderboard. Ooh. So Jeff is in the lead, Oakland is second, and then Rolski is third. All right, we got two more science-related questions for tonight, and then we'll move on to different topics. So our next question is, how does water vapor contribute to the updraft buoyancy in a convective cloud or thunderstorm? Is it increased heat capacity, latent heat of condensation, increased vorticity, or precipitation drag? All right, I'm going to do the countdown. 5, 4, 3, 2, 1. All right, 29 of you got it right. It is latent heat of condensation. So if we just take a cross section and just kind of take a moment to take how clouds actually form. So the latent heat of condensation, it adds heat energy to the air parcel as the water vapor condenses into liquid droplets and helps create that like buoyancy. So this is kind of a diagram looking at like the structure of clouds forming in a hurricane, a tropical system, and it's very similar over land. So immediately after the lifting begins and the air parcel starts to the rising parcels of warm moist air begins to expand and cool, and as that during that condensation process and the latent heat is released, so much of that energy is used in the thunderstorm to development. And as the heat is released within the cloud, it actually helps create that rising environment. So it can continue to be buoyant and can go up to very high altitudes. So Ashton, anything else you'd like to add on latent heat?
Nope, nothing to add.
All right. So with that, we are going to get ready to move on to our next question. Oh, well, I got to do leaderboard first. So let's see where we're at. All right. How much of a change did we actually have? Not too much of a change. For anyone who has been having problems or been kicked out, you can join us at menti.com and you can use the 8-digit code that is located at the top of the screen. It'll bring you back in. If we're in the middle of a question, it may not allow you to answer that question, but it will allow you to answer the next question. All right. So we've got one more question that we're going to get ready to do, and this is going to be our last question in science. And let's see how well you guys know information about microburst. So where's the highest ground level wind speeds in a microburst usually found? Is it in the eye of the microburst? Is it below the mid-air microburst, the lower portion of the ring vortex, or is the wind velocity uniform across the microburst? So those numbers are coming in pretty quick. Looks like we've got most of everybody. Let's see. All right, 40 people answered. 22 of you answered correctly. It is in that lower portion of the vortex ring. So I found this is actually from Encyclopedia Britannica in 2012, but it actually had that kind of nice little zoom in, so where it actually talked about that vortex ring. So microbursts are small. They're usually less than 4 kilometers across, and they only last for a short period of time. But in that short period of time, they can do significant damage with wind speed sometimes in excess of 100 miles an hour, which is even stronger than wind speeds from some low-end tornadoes. There are 2 kinds of microburst. There are both wet and dry microbursts. The wet microburst is accompanied by heavy precipitation, typically at the surface, while the dry microburst is usually kind of like where you would see those in the like the Intermountain West and the high plains, and they occur with like very little to no precipitation actually hitting the ground. Here in South Carolina, just I want to say it was last week or a week and a half ago, we had a pretty strong thunderstorm that may have produced a microburst, and combined with I think it was baseball size hail in portions just south of the Charlotte metro area, and those winds and baseball size hails actually contributed to a lot of damage in that particular area. So Ashton, anything you'd like to add on microbursts?
Yeah, sure. These can be a headache for forecasters in the summertime. Um, they move erratically and randomly, especially when there's not a ton of shear. And sometimes out in the Western U.S., they can actually start fires. And that causes a bunch of issue for firefighters and things like that. So these are a really challenging forecast problem for sure.
Thanks, Ashton. All right, so we are finishing the first theme for tonight. Let's take a quick look at our leaderboard and how much it has shifted. Looks like we do have some new people towards the top. Jonathan C. has come out of nowhere, it seems like. Oakland has taken 1 away from Jeff, who has moved to 3rd. So we're going to move into a new topic area. This is severe weather safety. It's near and dear to a bunch of our hearts. I know myself and Ashton and those of us who are Weather Ready Nation ambassadors and really try and promote severe weather safety. So we're going to spend a couple moments talking about severe weather safety. One of the first questions we're going to answer and ask here may seem pretty easy, and I have a feeling a lot of you are going to get this right. But not all questions are supposed to be hard. So, a tornado watch has been issued for your area. How should you respond? Should you find immediate shelter within an interior room or basement? Stay tuned to local media for the nearest information. Should you go out inside and play, or should you do both? All right, it looks like everybody answered, and 29 of you got it right. I don't know who the 2 of you that chose B and C, but I'm amused at that. So when we actually take a look at the definition between a watch and a warning, so a watch is basically you're going to stay alert, be prepared to take any action necessary. A warning means that there is an imminent danger, whether it is a tornado warning or severe thunderstorm warning. You need to take action and you need to find your shelter. And this is a question I have for you, Ashton, and I hate to put you on the spot for this, but I believe we had another question that was asked, and it was asked via social media, and it was about the lead time for watches. So could you give a little bit more information on that?
Yep. That's a really good question. And I think the lead times actually vary based on, event to event, from event to event. Um, I don't have those stats available right offhand to know what the average lead time is, but generally speaking, I think the goal there is to have at least an hour, in advance of the first event. But um, that's a good question. If whoever asked that question, if you could put me in touch with them, I can try to ask around and see and get a more firm answer.
Yes, I will definitely do that. So thanks, Ashton. I appreciate that. Hate to put you on the spot, but you're my expert sometimes. So I'm gonna use my expert to the best of my knowledge.
Follow me.
All right, let's see what the changes in the leaderboard are. Oh, just a little bit down at the bottom. Got some new people joining in on our top 10 there. All right, next safety question. Get everybody in. Going to go ahead and get started on that. So this particular question is going to be focused on as little as this much water can carry away, rushing water can carry away a vehicle. Is it 6 inches, 1 foot, 3 feet, or 5? All right, we can do the countdown here. 4, 3, 2, 1, and it is a foot. So when we're talking about, and I've got this great diagram here from the NOAA and the National Weather Service, so 6 inches of fast moving water can actually knock over an adult and actually carry away an adult. But it typically takes about 12 inches or a foot of fast moving water to carry away a small car. And it's not much more for those large SUVs, vans, and trucks. And so we've got this beautiful slogan that's come around, turn around, don't drown. So each year, more deaths occur due to flooding than any other thunderstorm related hazard. And so, over half of the flood related drownings occur when a vehicle is driven into basically water on the roads. Unfortunately, we as people, we underestimate the force and the power of water. And because of that, we kind of have this idea that it's just a little water on the road and we can go around it. But, those barricades are up for reasons. If you can't see the road, don't trust that it's there underneath all of that water. So, and Ashton, I know this is kind of right up your alley, as you really do focus on flash flooding for a lot of your work that you do. So do you have any additional comments?
Oh yeah, I saw a video today of an 18-wheeler. They got swept away in some water. It's trying to navigate a road with several feet. It looked like maybe 3 or 4 feet at least covered the road. And this was down in Texas recently, today actually, I believe. So it just doesn't take much. And even if you think you know the depth of the water beneath, what you may not know is that the road may be washed out or compromised in some kind of way. So it really is key to turn around and don't drown. Just find another way to get to your destination.
Yeah, and I want to say there were a bunch of flash flood warnings that were issued for the Houston area today, and I had been seeing some of that where people were still driving through those waters. So, we just want you guys to be safe while you're out there. So if you do see water on the road and there's a barricade, don't go around it. There's a reason why that barricade is up there. So let's take a look. Looks like Julie G. Oh, and Temple were both the fastest on that one. Got some answers, and just like that, like I said, don't count yourself out on these, because it doesn't take but one question to really turn the tide of our leaderboard. All right, so we're gonna get ready for our next question here. This particular question, a little near and dear to my heart, as I lived in this state for a while. What state is commonly referred to as the lightning capital of the United States? Is it Florida, Mississippi, Oklahoma, or Texas? Looks like a lot of you guys, like right off the bat, knew exactly what state you were going to pick. All right, 2, 1, here we go. Let's see. All right, most of you got it right. It actually is Florida. However, there are 2 different ways that you can look at these lightning counts, and I'd like to thank this is from the 2023 lightning report from Vasala. So you can look at it by the actual lightning count, or you can look at it by the density. So if you look at it by the count, it's just a simple number of the lightning events that have occurred. Texas always seems to have the highest lightning count. That's due to its size compared to other states. You can see last year, 42 million events and Florida coming in second place with 19 million events. So we typically like to look at lightning counts by density. And by doing it by a density, it helps compare lightning activity across regions, states, counties, even countries of different sizes. So when we refer to Florida as being the lightning capital of the US, it's because we're looking at those density values. And, one of the other interesting things that came out of that report is what was the top 20 most lightning prone US metropolitan areas in 2023. And Florida cities take the top 5. So, with Miami, Fort Lauderdale area, with the density having the most lightning prone metropolitan area in the US in 2023. And of course, that was followed by Palm Bay to Melbourne, Cape Coral, Orlando, and Jacksonville. But if you actually kind of look, most of the more lightning prone areas are cities that are, along the Gulf Coast states. We've got a couple that are kind of stand out a little bit, that aren't necessarily along the coast. But yeah, Florida is definitely the lightning capital of the US. So Ashton, any little final thoughts on all those numbers you're seeing on lightning strikes or lightning events?
Well, Florida's situated with warm bodies of water all around on almost all sides. And during the summertime, they get the sea breeze. They can get thunderstorms almost an accident. And then during the wintertime, they get, mid-latitude waves that move through and cause lightning that way. So just climatologically speaking, it's a really good place to be if you like thunderstorm activity in general.
Lived in Florida for 20 years, and I could always count on a thunderstorm about 4 o'clock in the afternoon. So I don't know if we have any other Florida natives in the house tonight, but I'm pretty sure you guys would agree with me on that one. All right, so let's see. Most of you got it right. So let's see who actually got this the fastest. And it looks like Julie G got it the fastest, and there was not. And Merrick did too. Merrick Sully got it too. But there wasn't much change in our leaderboard with that question. But we're going to go on. We're going to ask another safety question here. Oops, you guys didn't see that. All right. So the question that we actually have for you guys is, how long should you wait to resume outdoor activities after the last lightning strike or thunder occurrence? Is it after the warning is expired, 5 minutes, 15 minutes, or 30 minutes? I love watching these numbers come in fast. It means that you guys either are really confident in your answers or you know it. So got 2, 1, here we go. And 33% of you, or 33 of you, are actually right. You should be waiting 30 minutes after that last lightning strike or thunder occurrence. So these two graphics are really kind of interesting. One's from the one on the left-hand side is from NOAA, and it was done with the Lightning Safety Council. And it just kind of shows you the lightning risk and the exposure risk. So when a thunderstorm is approaching, you may have low lightning risk, but you have high exposure risk. Most people go inside when the thunderstorm is overhead, but then as soon as the thunderstorm departs, they go back outside. But that thunderstorm, they can have, and if you look at the little graphic here on the right-hand side, the concept of the bolt out of the blue, where you end up with a lightning strike that is well outside of the main cell of the thunderstorm. So the bolt out of the blue is basically a cloud to ground flash. And these flashes have been reported as far as 25 miles away from the main apparent thunderstorm. And they can, travel a great distance in clear air. So they, come down at angles, they strike the ground. This is one of the reasons why they tell, give 30 minutes after that last rumble of thunder, because if you can hear the thunder, you are close enough to be struck by lightning, even if you don't see the lightning. So it's always imperative to give as much time as you possibly can before resuming those activities outside. Ashton, do you have anything else you want to add on lightning?
Nope, nothing else to add. This sums it up real well.
All right. So let's see. Of the 33 of you who got it right, who was the fastest this time around? Oh, Jeff was the fastest, but we didn't have much change in our leaderboard. We're still pretty close. We still got some questions left. So again, don't give up. All right, this is going to be our last question in weather safety. Again, remember, correct answers fast correct answers get awarded more points. So what weather hazard kills more people in the US than any other hazard? Is it tornadoes, hail, flooding or extreme heat? All right, most of you are in. I've got 5, 4, 3, 2, 1, and all right, 20 of you are right. So flooding is the one that causes the most fatalities associated with thunderstorms. But overall, heat is the number one weather-related. Unfortunately, we have more fatalities from heat than any other hazard, and that's even combining flooding, tornadoes, and hurricanes together. So just this is the 2022 statistics. We still don't have really good numbers. We're still going through the CDC data for the 2023 statistics. So there were over almost 400 weather-related or heat-related fatalities in 2022, and you can kind of see the 10-year and the 30-year average. So I've got the key point there. Unlike other forms of extreme weather, heat waves do not possess any telltale signs. Severe thunderstorms, they produce, phenomena like tornadoes, lightning, hail, even strong winds you can see that are easily identified as being harmful. But heat waves are often accompanied by those sunny days and relatively benign weather with like light winds and no rains. It's the one where we go outside, we're having a great time. But despite this, heat waves are exceedingly dangerous. And we still have to be treating them with proper precautions. Currently, we're in the middle of National Heat Safety Week. So NIHIS, which is a collaboration for a bunch of federal partners, and that includes NOAA, National Weather Service, CDC, OSHA, are trying to get the information out there on being heat prepared and ready as we get ready to get into the warm season. So I think 20 of you got it right. Let's see who got it the fastest. Let's see. YJL got it the fastest. There's a little bit of shuffling there at the top of our leaderboard. So with that, we are going to get ready to move into our third topic, which if you guys were with me in the fall, I am a history buff. I love history, and I love it when it actually coincides with historic weather events. So we're going to focus on some of the more historic, severe weather events. I've got some questions here for you guys to answer. So, the last section was kind of a little bit of an easier section. We started off a little hard with science. This one's going to be for the history buff. So if there's anybody out there who's a history buff, you guys might do really well in this particular section. All right, let's get started with our first question. In what month was the first successful tornado watch issued? Was it March 1952, June 1953, September 1954, or April 1955? I'm actually seeing these numbers come in pretty fast, so I'm hoping that you guys actually you guys know this. 14 of you actually had the correct answer. It was March of 1952. And I'm going to thank Ashton for pointing these papers out to me because this is fantastic. These are the aerial extents of two different events that happened in March of 1952. The first being the one on the left-hand side where you can see the polygon that was drawn, and then you can see the two little marks for the tornadoes, and then you can see the one on the other side that happened a little bit later in March. It was just like, I think 4 days later, and you can see the two different polygons and then the tornadoes from there. So it was a group of, and I have to remember, and Ashton, I may have to call upon you but I believe it was like 15-ish forecasters that were from the severe weather unit that was like a trial basis with the Weather Bureau Army and Army and Navy Analysis Center. Is that correct?
Yeah, and actually, I think Steve Graffiti was the one that documented all this, so he's probably the expert, the resident expert to ask about a lot of the early days of what we now know as the Storm Prediction Center. But yeah, the first successful tornado forecast in 48 kind of laid the groundwork for some of this. And so moving forward, some of the decision makers decided to put a unit together to specifically focus on severe weather. And they actually got a really big outbreak with about 200 fatalities there in eastern Arkansas and western Tennessee. And you can see the watches there, the second and third watch ever issued by that unit, the predecessor unit to the Storm Prediction Center right there on the right-hand screen of the graphics. So yeah, it's just a fascinating case It's also kind of tricky too because a lot of people might have thought that March 1948 was the first successful watch, but it wasn't. It was the first successful warning, and it was a base warning for a tornado that ended up forming a week later after the same type of pattern showed up, synoptic pattern showed up in central Oklahoma. But this one was more of the first successful watch, and again, it just kind of demonstrated that even back then, advancements were being made, and there was enough skill to actually start putting out these bulletins.
Yeah, and if we can maybe in the forum post the paper that you provided that actually goes into like the birth of the Storm Prediction Center, that has a really good rich history of this particular event and others too. So let's see. There we go. Oh, we got some new people down in the lower. See, like I said, you just got to watch. Things can change. All right, who was the fastest on that? KD4PYR. Thank you so much for joining us. All right, let's go on to our next question. We got 4 questions left. Still anybody's game at this point. And this one's going to be another one. Tornado Watch 211 was written about the tornado outbreak in which year and month, responsible for the farthest east F5. Was it April 73, October 79, May 85, or May 89? Can't wait to see who got this one right. There we go. We've got some severe weather storm history buffs in the chat tonight, because that 18 of you got it right. Actually, every single one of those months and years actually is a severe or tornado outbreak that's been recorded. But this one particular is the one. This is sometimes known as it was a tornado that touched down in Ohio and actually tore across portions of Pennsylvania. It was one of the deadliest outbreaks in the 1980s. Unfortunately, nearly 90 people, I think it was like 89 people, lost their lives and injured more than 1,000 others. It is the farthest east F5. It's actually the only F5 in Pennsylvania history. And it was the most violent tornado reported in the United States in 1985. So you can actually see the remains of a shopping center in Ohio. And then there was a trucking plant in Wheatland, Pennsylvania. So there's a picture of the book that was written about that particular one. And actually, I've got Steve quoted in here about that particular event as well. Talking about, 8 years after the event, the path of the nearly mile-wide monster storm remained nearly devoid of trees, in stark contrast to the richly green forest surrounding it. Anybody who's ever passed by tornado damage realizes that it definitely leaves a scar. The storms there was a lot of instability and environmental factors that went into that particular event. And it was really triggered by the passage of a late spring cold front. The survey reported in 1985 by NOAA said perhaps the lessons to be learned from this outbreak is that under the proper atmospheric conditions, major tornadoes can occur regardless of location or terrain. So that's kind of some kind of interesting things that came out of that particular report that I read through. I'll tell you, I get a kick out of looking through some of these reports and reading through the information. So let's check our leaderboard.
Hey, Melissa.
Yeah.
I just want to add a couple things.
Sure.
The gentleman who issued that watch was actually on the panel for the 1974 tornado outbreak. And it was a fascinating case where there was an elevated mix layer that made it all the way out to Ohio and Pennsylvania, which is a bit unusual. There was a cold front. I don't recall if there was a dry line or not necessarily, but that elevated mix layer allowed the boundary layer to heat up and cause a lot of instability to build, just like you see in plains outbreaks. But instead, that happened way far east in Ohio and Pennsylvania, which is unusual. Usually there's some convection that kind of develops somewhere in between the plains and, the Appalachians that would eliminate the risk of that EML or elevated mixed layer forming that far out to the east. So the Steve Weiss, I think, is a great resource if people know him and he's up in the Connecticut area. And I think he has some ties with the SUNY Albany, but he's a great resource for that outbreak because he worked in and issued that watch.
Oh, really? I did not know that Steve was the one who did that. So that's why I like these trivia nights. I always learn something new on them. All right. I'm going to go to our next question. So 3 questions left. We're going to go ahead and get started with our next question. In what month and year did the first billion-dollar tornado occur in the U.S.? Was it April 1974, May 1997, May 1999, or April 2011? All right, you guys are pretty quick on this one. 3, 2, 1. All right, 17 of you guys got it right. This is another anniversary coming up tomorrow. The May 3rd, 1999 tornado that went through Oklahoma City. So this particular tornado, not only notorious for causing $1 billion of damage, but it is also the storm that caused the words or the phrase tornado emergency to be considered to be used when talking about a tornado that is going to be approaching a large urbanized area. And so I've actually got the bulletin, the EAS bulletin right there that you can kind of take a look at, where it actually talks about, a tornado. This is a tornado emergency. This one is actually from the 2013 event, but you can kind of see that they've got the wording in there. So the science and operations officer at Norman at the time, he said, one thing, it became apparent that the unique and eye-catching phrases need to be used in our products to get attention for this particular event. And they used tornado emergency to paint that picture of a very rare and deadly tornado that was headed towards the metro area. So one of the other interesting things is that, the 2011 super outbreak actually set the all-time record for the most tornado emergencies issued by the National Weather Service in a 24-hour period. That was 16 tornado emergencies. And they were issued for areas including the Tuscaloosa-Birmingham tornado, the EF5 that went through Philadelphia and Smithville, Mississippi, and then the Rainsville, Alabama tornado as well. So, the 2011 outbreak had 216 reported tornadoes across the U.S. So, this particular event really did change kind of the way that we look at things, especially when it comes to these particular impactful tornadoes. So Ashton, I'd love to hear if you've got any additional insights on this one.
Oh yeah, well, we actually I co-authored an article with Bob. Name is drawing a blank. I'm so sorry.
Henson.
Yeah, Bob Henson. Yeah, gosh, I'm so sorry. Anyway, we co-authored an article that talks about how the emergency has changed over the years. And it's amazing. And even though this particular event was so devastating, how it really worked to change and improve the way we do things from, warning and a short-term mesoscale forecasting of severe and that standpoint. So, yeah, I just wanted to kind of bring that up. It's a fascinating case for a lot of reasons, and there's all sorts of documentation, radar observations, just fascinating, even though it caused a lot of impact.
And so one of the things I'd also like to point out is that particular article is available. It was posted, I believe, towards the end of last week, early this week, on Weatherband. So if anybody is interested in that particular article, you guys can go read it and learn more about this particular event. So let's take a look at how our leaderboard has changed. Big Salsa's, welcome to the top. Nice to see you on the scale there. All right. Let's go to our next question. We have 3 questions left. All right, here we go. In what year more than 1,000 people died in the U.S. from heat? So was it 1993, 1995, 2006, or 2012? I'm watching the numbers. All right, we'll start the countdown. 3, 2, 1. Let's see. And 13 of you got it right. The heat wave of 1995 broke records, especially in the Chicago area. more than 500 people, unfortunately, lost their lives in Chicago and across the Midwest due to these high temperatures. So you can see I've got a image from the Chicago Sun Times from the middle of July talking about the heat toll could hit 300. And then we've also got, thanks to the NWS or the Chicago Midway station, thanks to the Illinois State Climatologist for kind of printing or posting the highs and lows for the for July for the first 20 days of the month, and you can see those maximum temperatures, pushing 106 degrees. But one of the telltale stories on that too is the overnight lows did not drop below 75 there for almost 4 days in a row, with actually a low of only 84 degrees on the 14th. It's extremely high. It doesn't give the body a chance to like come down off of all of that heat that's been absorbed through throughout the day. The only other documented high temperature at Chicago, any Chicago site, over 100 degrees, was actually during the Dust Bowl in 1934. There's a couple of different papers that have been put out in bands that are available online, so you can check it out. This particular heat wave has a couple of different articles, but one of the articles I was looking at, they noted heat waves of the 1911, 1916, 1934, 1936 in the Midwest that were kind of comparable with this one. And one of the major factors that helped influence the severity of this particular heat wave, and then the one that occurred in 1999, was the urban heat island effect. So the high concentration of buildings and roads and urban areas, the surfaces tend to absorb more heat during the day, and then they release it into the atmosphere at night, which is one of the reasons why those low temperatures don't necessarily drop, is because of that. And then those urban areas experience that less cooling than versus, just outside of the urban areas and more rural environments. So, Ashton, did you have anything you wanted to add to this particular one?
Nope, not
All right. So let's take a look at how our leaderboard has changed. We got Doppler Deb. All right. A little bit of changes going on towards the top, but we have 2 questions left, so don't give up hope yet. All right. Everybody in, and we'll get started with our second to last question. What was the diameter of the largest recorded hailstone in the U.S.? Was it 6.42 inches, 7.36 inches, 7.75 inches, or 8 inches? Some of you were quick to jump on that one. We've got 3, 2, 1. Let's see. 15 of you were right. So the only made up hailstone size on that one actually is a 7.75. I am drawing a blank and I wish I had taken better notes, but the 6.42 and the 7.36 are record hailstones for individual states. I want to say one of them is Texas, and I want to say the other one is Alabama, but I could be mistaken on that one, so please don't quote me on that. But I can show you where we can go get those. So here's a picture of the divot that hailstone left, and then the actual hailstone itself. It fell in Vivian, South Dakota in June of 2010. It had a circumference of about 18.6 inches and weighed about a pound. The hailstone, actually, when it was initially collected, based on the person who collected it, they reported a diameter of 11 inches on this hailstone, but it deteriorated in the freezer because the observer who saw this picked it up and put it in the freezer, and that's where you can kind of see the divot there, and you can see the 11 inches kind of on that, and you can kind of see the spikiness on it too, because unfortunately the owner lost power after the storm. So this particular storm or stone actually could have been larger than what it was actually measured with. This stone also has the largest circumference of a hailstone on record in the United States. So, earlier we talked about Florida being the lightning capital of the United States with, so many thunderstorms and lightning. But when we want to talk about states with the most hail, that is going to be Colorado, Nebraska, and Wyoming. Typically have more hail than any other states in the U.S., and they usually average about 7 to 9 hail days, meaning hail is observed on 7 to 9 days per year. So, Ashton, do you have anything you want to talk about this particular hailstone?
Nope. Other than, a lot of people regard severe thunderstorm warnings as kind of like a next tier compared to tornado warnings, but that's not always true. If you've got, big hail and strong winds that are coming and the strong winds are blowing the hail sideways, that can be as damaging as an F0 or F1 tornado. It can break windows, it can punch through roofs. Hail can get on the inside of homes. Vehicles are risky. Um, yeah, I guess I used this example to kind of say that all warnings should be paid attention to.
Yes, exactly. And this storm was actually warned on. I did check on that. So let's take a look at the leaderboard real quick, see what changes have happened. Well, we still have a pretty tight, I was gonna say, it still could be anyone's game with these last few, this last question I actually have, and I'm taking a look at it right now because I want to make sure. So yes, sorry, Texas and Kansas were the other two. I just pulled that up to take a look at it because I wanted to make sure I actually had that right. All right, so last question for trivia night. Hopefully you guys have enjoyed yourself. You've learned something. And let's see who's going to walk away the winner for trivia night. All right, last question is, what is the highest 24-hour rainfall total observed in the U.S.? Is it 20.73, 25.83, 42, or 49.69 inches? You guys were pretty quick to jump on this one, so I feel like you feel like you might know this one. So let's see who got it right. 18 of you got it right. So actually every single one of those values does represent a 24-hour record rainfall for a state. The 20.73, if I remember correctly, is from Tennessee, and that was from the Waverly event that just happened in 2021. The 25 inches is the 25.83 inches is going to be from California, and that happened in January of 1943. The 42 inches, which was the previous record, is actually from Texas, and that happened with Alvin in 1979. And then, of course, the 49.69 inch record, which actually is from Hawaii, and that occurred April the 14th through the 15th of 2008. So just to kind of give a little bit of overview, there were 3 different episodes of this intent that caused this event over a 24-hour period. This is on one of the islands of Hawaii, and most of the rain events that happen in Hawaii usually happen at the higher elevation, but the first rain event actually happened at a lower elevation, and it caused some problems. And then the second intensity episode was a little bit later. It was around like midnight, so you can kind of actually see the jump here in the 15-minute rainfall totals. And they were seeing rain rates on average of 5 to 7+ inches an hour. And that heavy rain covered most of the drainage basins. So you can see there were wiped out roads, unfortunately. Homes were destroyed. But the key, you just take a look at like the total. So these are the maximum like 15-minute, 1 hour, 6 hour, 12-hour rainfall totals from this particular event. And it really was thunderstorms that just kind of came, just kind of trained over that particular area, and kind of like cycled and fed off of each other. They did very little movement in those particular storms, in that particular thunderstorm series over that island. So just, when you think about that, that is more than some of the Western states or Western United States pick up in a year. They picked up in 24 hours. So, all right. So final numbers are in. Let's see what our changes are. Who are our winners? All right, there we are. So y'all, thank you so much for joining us this evening. I hope that you have you've learned something. You're walking away with a little bit more knowledge and even some trivia that you might be able to talk to your family and friends about severe weather here. And I'm going to turn it over to Gideon now to close us out. Gideon, the floor is yours.